Hello everyone, welcome back. This video will solve two sums problem using approach to hashing. Before solving the problem, let me introduce hashing in a simpler term. So what is hashing? Hashing is nothing but storing data in a way that allows very fast lookup, right? Example, take a dictionary. So this dictionary will have a lot of words. If suppose you want to find out a word, you're not going to read page by page to find the word of your choice. You're going to go directly, use a first letter and search. Yes? So in programming terms, in computer science terminology, we use a hash table or simply a hash which stores key value pairs. So what is hashing? It's a technique that maps keys to indices using a hash function that will enable faster data retrieval in constant time, that is order of 1. So this is the primary advantage of using hashing. Now let us solve the same two sums problem using hashing. Yes, this is my main function. My nums is the array. I'm taking the same example 2, 7, 11, 15. N is equal to 4. Target is equal to 9. I call a function. Yes, the name of the function is toSum. Right. There is a hash define scene. Hash define max of 1000. Right? Okay, so we are creating a fixed size hash array of size 1000. So this assumes all numbers in the array are less than 1000 and are non-negative. Fine? Okay. Next, inside the function, what I'm trying to do, I initialize my hash, int hash of max, and then using a for loop, I say hash of I is equal to -1. Means hash of 0 will be equal to -1, hash of 1 will be equal to -1, initially hash of 2 will be equal to -1, etc. Why -1? -1 means the number is not seen yet. Okay, so that is the reason of initializing it to -1. The next part is the important key idea, right? I use a for loop which runs n times. For int I equal to 0, I less than n, I plus plus. Okay, I'm computing the complement. Complement is equal to target minus nums of I, right? Yes, I is equal to 0. 0 is less than 4, n is equal to 4. I'm finding complement. What is complement? Target minus nums of I. What is nums of I? Nums of I is equal to 2. Nums of I is 0. So nums of 0 is equal to 2. Complement is equal to 9, which is the target, minus 2. So complement becomes 7. Yes, I'm checking. What I'm checking? If complement exists. What is my condition? If complement is greater than or equal to 0. Yes, complement is greater than or equal to 0. And hash of complement not equal to -1. What is hash of complement? Complement is 7. So hash of complement. Hash of complement is what? Right? Hash of 7 is -1. We have initialized it to -1. So it is not found. So the printf doesn't get executed. I am storing the index of the current number. How I am storing the index of the current number? Hash of nums of I equal to I. So hash of, what is nums of I? Nums of I is nothing but 2. Hash of 2 is equal to 0. So I am storing hash of 2 as 0. Right? Hash of 0 is -1. Hash of 1 is -1. Whereas hash of 2 is become 0. Iteration 2, what happens? I equal to 1. Okay. So nums of I is 7 now. You are calculating the complement. What is complement? Target minus nums of I. Complement becomes 2. So hash of 2 is equal to 0. Yes, complement is greater than or equal to 0. So the condition is satisfied, found. So you are printing the indices. So you print the indices 0, 1. So what is the difference between approach 2 and approach 1? Approach 1's time complexity is order of n squared, whereas approach 1 will be very easy for a beginner. Approach 2, it is not that tough nor easy, but it is an optimized code which runs for a time complexity of order of 1. Order of n. Done. So let us break down for better clarity and understanding. So this is what is the function doing. The function is initializing all the values to -1 in the first iteration. Fine. So this is what is the visualization part if you want, followed by the computation part. The current number is 2 as we discussed. Complement is 9 minus 2, which is 7. You are checking 7 is greater than 0, but hash of 7 is equal to -1. So I am not printing the indices, rather I am storing the index of the current number. So we store 2. Hash of 2 becomes 0 here. Done? Okay. Next, in the second iteration, the current number becomes 7. Complement becomes 9 minus 7, which is equal to 2. So check, yes, the condition is satisfied. Hash of 2 is equal to 0, found. So I am printing the indices 0, 1. Right? So we have solved the two sums problem using approach 2, which is hashing. Any doubts, post it in the comment section. Happy learning. Thank you so much.